This is Professor Derf Seitz. This algebra tutorial is the second of 4 parts. Which focus on solving quadratic equations. Part 2 here uses the square root property. The square root property, if you have an equation of the form a squared equals c, this implies that a is plus or minus the square root of c. Capital A here can be any algebraic expression. It does not have to be a simple variable. It could be a binomial. Plus or minus is a prefix that represents two alternatives, one plus or one minus. It means two things. Example 1, x squared equals 9. We can apply the square root property and rewrite this as x is equal to plus or minus the square root of 9. The square root of 9 is 3, so we have plus or minus 3. Our two solutions are x equals 3 or x equals negative 3. In example 2, we have a binomial squared. X minus 25 is the capital A here in the square root property for this pattern instance. Dropping the square and taking the square root and plus or minus, this becomes x minus 25 is plus or minus the square root of 100, and that's equal to plus or minus 10. Adding 25 to both sides, x is equal to 25 plus or minus 10, and this breaks down into x is 25 plus 10 or x is 25 minus 10, giving us 35 and 15 as the two solutions. Example 3, x squared equals negative 7. Applying the square root property, this becomes x equals plus or minus the square root of negative 7. This is plus or minus the square root. Negative 7 is negative 1 times 7. Using the product rule of radicals, this becomes plus or minus the square root of negative 1 times the square root of 7. And the square root of negative 1 is the imaginary number I. So this can be written as plus or minus I times the square root of 7. I is the imaginary number defined as I equals the square root of negative 1, or equivalently, I squared is equal to negative 1. Imaginary or complex numbers are not real numbers. Every real number is an imaginary number because complex numbers are of the form a plus b times I, where a and b are real numbers. If b is 0, we get the real numbers. Remember that the imaginary or complex numbers, they exist in what's called the complex plane, where one axis is a real axis and the other axis is the imaginary axis. In multiplication there, since it's defined as I squared equals negative 1, it's a different kind of multiplication that goes beyond what we do with real numbers. So you should not be disturbed by the fact that I squared is equal to a negative 1. Continuing here, it's because a plus bi is the standard form for complex numbers with I on the right and the coefficient b on the left, we switch the order of I and the square root of 7 to make this plus or minus the square root of 7 times I. Note that the I here is outside the radical. It's not square root of 7I, it's the square root of 7 times I. So our two solutions are the square root of 7 times I, and or the other solution is negative square root of 7 times I. Both complex numbers. Example 4, we have a quadratic equation where the left-hand side happens to be a quadratic in vertex form. If you haven't studied vertex form yet, that's all right, but it's good to be exposed to things that you'll learn later on in the context of something you're learning now. It turns out that when it's in vertex form, you can read off the vertex, and for this particular one it becomes 3 and negative 5, because in vertex form there's normally a minus sign here and a plus sign here, and that's what makes one of them a minus, because this is a minus of a minus to get a plus. But anyway, back to what we're trying to do is to solve this using the square root property. First we have to add 5 to both sides, because we have to have something squared on the left. The minus 5 has to move. Now we have something squared equals 5. It's this binomial. We apply the square root property. We get x minus 3 is equal to plus or minus the square root of 5. Adding 3 to both sides, we now have 3 plus or minus the square root of 5, and the two solutions are 3 plus the square root of 5, or the other solution is 3 minus the square root of 5. If we look at the graph of this quadratic, x minus 3 squared minus 5, we see a parabola here. This is the x-axis and the y-axis, and there's the parabola. Its vertex, its lowest point here, and it's symmetrical on either side of the line of symmetry that goes through this vertex, is the point 3 minus 5. This becomes 0 when the y-axis value is 0, and that's where the parabola crosses the x-axis. Those are the two solutions that we just found. And if we compute 3 minus the square root of 5 and on a calculator and round it off, it's approximately, that's what that sign there means. It means approximately equal to 0.76, and 3 plus the square root of 5 is approximately 5.24, and those are the two places where the parabola crosses the x-axis. So we see here for a certain types of quadratic equations, using the square root property makes it very simple to find the solutions, and in particular when a quadratic is in vertex form, it's a very simple way to find the solutions.